Hello, we're back again for another video. This is performance task number 2. And again, my name is Carl Joseph Rizal, a BS ECE3A student. So today's topic is about line coding. So what is line coding? Line coding is also called a digital baseband modulation or digital baseband transmission. It is a process carried out by a transmitter that converts data in the form of binary digits into a baseband digital signal that will represent the data on a transmission line. So, transmission line in question could be a link between two devices in a computer network, or it could form part of a much larger telecommunications network. The receiver is responsible for converting the incoming line coded signal back into binary data. So we have here the five categories of line coding. We have unipolar, bipolar, differential, multi-transition, and multi-level. So today we will talk about more on multi-level. So, multi-level line coding. It is the desire to increase the data speed or decrease the required bandwidth which resulted into the creation of many schemes. The goal is to increase the number of bits per baud by encoding a pattern of M data elements into a pattern of N signal elements. We only have two types of data elements, so which is zeros and ones, which means that a group of M data elements can produce a combination of two M data patterns. So if 2M is equals to Ln, then each data pattern is encoded into one signal pattern. If 2M is less than Ln, data patterns occupy only a subset of signal patterns. The subset can be carefully designed to prevent baseline wandering, to provide synchronization, and to detect errors that occur during data transmission. Data encoding is not possible if 2M is greater than Ln, because some of the data patterns cannot be encoded. The code designers have classified these types of coding in encoding as MB and L, where M is the length of the binary pattern, B means binary data, and N is the length of the signal pattern, and L is the number of the levels in the signaling. A letter is often used in place of L. So we have here B for binary, for L is equals to 2, T for ternary, for L is equals to 3, and Q for quaternary, for L is equals to 4. Note that the first two letters define the data pattern and the second two define the signal pattern. So in multi-level line coding, we have the 2B1Q, which will gonna be the topic for today. So 2B1Q, the first MBNL scheme we discuss, 2 binary, 1 quaternary, uses data patterns of size 2 and encodes 2-bit pattern as one signal element belonging to a 4-level signal. In this type of encoding, M is equals to 2, N is equals to 1, and L is equals to 4 quaternary. In 2B, 1QL line coding scheme, a block of two binary bits can represent four different values. We have here 00, 01, 10, and 11. These four values are mapped to one quaternary value, which is encoded using four different voltages. The first bit represents a positive or negative voltage, and the second bit represents either 1 volt or 3 volt line potential. The following table shows the four possible combinations. So if we use the redundancy, we can decide to use only 0 or plus weighted codes 4.43, more positives than negatives in the signal element, and invert any code that would create a DC component. Receiver will know when it receives a negative weighted code that it should invert it, as it doesn't represent any valid symbol. So we have here the tables for the next bits. We have here 00, 01, 10, and 11. For the previous level positive, we have the value for 01, which is positive 3. We have for 00, we have positive 1. For 10, we have negative 1, and for 11, we have negative 3. Note that it's the voltage. So next is in the previous level negative. So we have here for the value of 00, We have here negative 1 for the value of 0, 1. We have here negative 3 for the value of 1, 0. We have positive 1, and for 1, 1, we have for plus 3. So here is the example. Okay, wait for a minute. Um, Pointer. So we have here highlighter. So we have here the bandwidth, or how we plot this table. So first is we have here positive 1 for 0, 0. Because the previous level is positive, so we need to find the value here on this table. For 1, 1, we have negative 3. So we will go down, or we will step down here for negative 3. And because of the previous level is negative, so we're going to find the values for the next in this kind of table. So next is 0, 1. And now we have here in the previous level negative um, uh, 0, 1. So we have here negative 3. So it will continue in this part. And next is previous level is negative, and the next is 1, 0. So we need to find here again. So 1, 0 is positive 1. So we have here positive 1. And again, the previous level is positive, so we need to find here the values. So next is 0, 1. So we have here positive 3. So this is the bandwidth of the table above. So here we start here and then going here. Okay. The average signal rate of 2B1Q is equals to n divided by 4. This means that using 2B1Q, we can send data 2 times faster by using NRZL. However, 2B1Q uses 4 different signal levels, which means that the receiver has to discern 4 different thresholds. The reduced bandwidth comes with a price. There are no redundant signal pattern in this scheme because 22 is equals to 41. So we have here another example. This is the ordinary binary transmission, and this is the 2B1Q coding, which we discussed earlier. So the result of 2B1Q line coding for BRIISDN is that a single electrical pulse represents 2 binary bits instead of 1 binary bit. This effectively doubles the possible bandwidth of the communication channel as shown in the illustration. So benefits of 2B1Q line coding: there are no redundant signal patterns in this technique. It is used in digital subscriber line DSL to provide high-speed internet. Typical codes balance voltage leads to lesser baseline wandering. So we have here the summary. So 2 Q coding scheme. A block of 2 binary bits can represent 4 different values: 0, 0, 0, 1, and 1, 0, and 1, 1. Effectively doubles the possible bandwidth of communication channel, and it uses a digital subscriber line DSL to provide high-speed internet. So that would be all. Thank you.